All right, let's start with the 1.2. The first objective is about equality and inequality symbols. So we have one equality symbol. If we say this symbol means A is equal to B, is equal to, right? This symbol means is equal to. And similarly, we have this symbol means is not equal to. A is not equal to B. Not equal to. And we also have this symbol. A is less than B. So this symbol means is less than. Of course, we also have greater than. So this symbol means is greater than. But make sure you know we also has this symbol, both less than and equal to. So this means is less than or equal to. So A can be equal to B or A is less than B. So the last inequality symbol will be like this one. Is greater than or equal to. So A is possible greater than B, is also possible equal B. So let's check if we have a number line. We have two numbers, let's say A and B is on the same number line. And we check this one, we realize A is left to B, right? This is A is left to B or B is right to A. So this we can say A is less than B. We can use this inequality symbol. A is less than B. Or B is right to A. We can say B is greater than A. Both are correct because they have the same meaning. Okay? So we can check some example. This example just want to say true or false. First, we say true, 2 is less than 3. Since if we put 2 or 3 in the number line, we will have something like this. 2 is here and 3 right here. So, because 2 is left to 3, so we will say it's true. It's true. So if we say 8 is greater than or equal to 8, is that correct? Is that true? We will say yes, because 8 is equal to 8. So 8 is also can be say is greater than or equal to 8. So this is also true. Okay, how about this one? 23 is less than or equal to 0. So first of all, 23 is not less than 0. 23 is also not equal to 0. So this is false. Okay, that's for the first objective. Let's check the second one. Second one, we just try to translate a sentence into mathematical statements. Right? So we just want to translate the words into symbols. Let's just see some examples. Translate. So example first, we say we have this kind of sentence. 9 is less than or equal to. So make sure you know 9, of course, we can use this, is less than. So first we put less than or equal to, which means we should add this one. Less than or equal to 11. So that will be our answer. Okay. So make sure here you watch the symbol. This means less than or equal to. For example, we will say this time we have this sentence. 8 is greater than 1. So we try to translate. 8, so we put 8. And is greater than, so we only need to put this symbol. Greater than sign. Greater than 1, so we put a 1 here. Alright, and the last sentence we have here is 3 is not equal to 4. 3, so first we put 3, is not equal to, so we have a not equal to sign, is not equal to 4, so we put 4 on the right. So that's it for this objective. Translate. Okay, next one will be try to identify common sets of numbers. Identify. So we know we have several concepts of the numbers, right? First, we know whole numbers, right? Whole numbers are 0, 1, 2, 3, and so on, right? This is whole number. And we also know natural number or counting number. Counting number or natural number. It's just 1, 2, 3, and so on, right? But here we should learn something new. We call it integers. Integers. Integers can be smaller than 0, can be less than 0, which means integers can be negative numbers. So it's possible to have -3 or -2, -1, 0, 1, 2, 3. And so on. Also can be smaller than -3. So this kind of set of numbers, we call it integers. So it is possible to be negative number in integers. But for the natural number, it's all positive number. And whole number, we have 0 and all the positive number. Okay. So this is just want to show you we have integers. Of course, we have another concept called rational numbers. Rational numbers. So we use this symbol to represent rational numbers. So any number can be represented by this form. A over B. A and B are both integers. And because B is denominator here, so b is not equal to 0. Any number can be expressed by this form. We call it rational number. So most of time we refer to rational number as fractions. Fractions. Okay. So if we have rational number, we also have irrational number. Irrational number. So irrational number, we can have some examples. Something like square root of 2. But this number cannot expressed by a over b. Cannot follow that form, right? It's square root of 2, or we will say pi. These are two examples of irrational numbers. But here we should know both rational number and irrational number can be written as decimal numbers. Decimals can be decimal numbers. Okay, so for example, we can write a rational number 3 over 4. So this number follow the a over b format, right? So this is 3 over 4. We call it a rational number, and we know if we transform the fraction to the decimal, we get 0.75. So rational number can be expressed by the decimal. And let's check pi. Pi is an irrational number, and we can also use decimal to express it. Something like that. Okay, so both irrational number and rational number can be written as decimal numbers. So put them together. We will say rational number plus irrational number equals real number. So equals real number. And any real number can be found in your number line. Any real number can be found in your number line. Okay? So we use a table to represent the relationship of all the numbers. First, we talk about real number. Real number consists of irrational number and rational number. Okay, rational number has integer number and non-integer. Okay, if integer number can be negative integer, can also be whole number. Then we try to see the whole number. Whole number can be 0 and natural number or counting number. So something like 1, 2, 3, 4. So this one shows the relationship from real number to natural number. Okay.